You guys are here already. Let me fix this. Does that work? Yes, it works. So please download exercise 4. Today is actually pretty easy. Oh, that depends. Hey, it's pretty easy. But it's one of the most important techniques. You should be able to do it in no time. I need to 4. Following exercise 4. What I want to do. Okay, this one. So then this ship, ship. This guy. Oh, so it's not teaching. Okay, and this is not yours, by the way. Let me get that away. Yours is much easier than that. We're gonna cover whatever I wrote on the other page because that's like the real job. We're gonna cover that maybe at the very end of the term when you will be able to solve some really cool physical problem. For those of you who learn Algo, you may appreciate whatever we learned at the last class. That 99%, not 99, let's say 80% of the problem can be written as one way. There's one way to express like 80% of the problem. Get the notebook up. Exercise 4 and then there. Okay. So, Ajanka, is this curve fitting? Right. Yes, it's that one. It's the one that say, if you open it, it say linear equation and linear regression. You can see that the notebook is actually fairly short. It's fairly short today. So we have 2 things to learn today. Okay, let's start real quick. Because if we can get this thing out of the way, then you're gonna be so proud of yourself that you can actually build something that looks really cool, that does something, I would say nothing short of magic from scratch. Okay, it looks very magical the first time you see it. So let me explain to you. The goal today is actually to do this, to do curve fitting. The real goal today is actually to do that. Okay, so what is the problem that we are trying to solve? We are trying to solve the following problem. Okay, when you see data points, right? So for those of you who learn machine learning and whatever the one that Ajahn Bull taught, what's it called? Intro to data science or whatnot, right? The goal here is you have a whole bunch of data. If you have a bunch of data that looks like this, somehow human understand and that this is a trend line for that data. Humans sort of understand that, right? This is a trend line, right? We're gonna find that line. That's the goal for today. But we need a little bit more math to be able to do that. Okay, so far so good, right? That's the real goal today, but we need a little bit more math to be able to do that. So let's learn the background math first so it doesn't get into the way, okay, when we try to do it. So let's do this, okay? So the first thing that we're gonna learn is something called linear equation. Well, system of linear equation, not linear equation, system of, okay? So these are the problem of the form, I don't know, let's say x plus y plus c is 6, right? This is linear. You have 3 variables and the equation is linear. So that means this is not x squared plus sine x plus e to the c equals 6. No. This is not linear. Linear means is some constant times x, some constant times y, and some constant times c equals 6. Okay? Right? You probably learned it in like, what's it called? The basic baby math class. And then you have 2x plus 2y. Let's say plus 3y plus c. That is equal to 11. And maybe you have the other one, which is called minus x plus, let's say minus 3x plus 4y minus 2z. And that is so far so good, right? So these are the things that we try to get the computer to solve today. Any question though? This is the real goal, not the real goal, like the first goal that we try to do, right? We want to be able to like put in this guy to the computer and then solve for me what is x, y, and z. So for this one, I made this equation back in my mind is, right? You know, it's very easy to make this equation in reverse. I know in my mind that x is 1, y is 2, and c is 3, right? So let me check real quick before we try to do this. 1, 2, 3 is 6. 2 plus 6. No, 2 plus 6 is 8. 8 plus 3 is 11. Minus 3 plus 8. That's plus 5. Plus 5 minus 6 minus 1. Okay. So the goal here is to get the computer solve this, which means it needs to give you 1, 2, and 3 as your answer. Okay. Any questions? Any questions so far, though? Any questions so far? And our algorithm should work for any sort of dimension. Okay. So for those of you who still remember what you did in like baby math class, what would you do to solve this? What would you do? Or maybe it's something that you take this term. Some of you might taking it this term, though. What do you suggest? How do you solve this equation for x, y, and z? Anyone? Anyone? Do you remember something from math class, right? You write it as a matrix. Okay, that's one thing, right? That's the first thing is you write it as a matrix. So let's do that. Let's do exactly that. Because computer loves the matrix. If you learn how computer keep data in RAM, matrix is the best form to do that. Because when you load data from RAM, it load the neighbor as well. Okay, so this is what you do. Okay, I hope everyone still remember that, right? Right, and then you say that, okay, Ajahn, this is like x, y, and z, right? And that becomes 6, 11, and minus 1. Right? So these two guys are equivalent. Okay. These two guys are equivalent, right? And the goal is to solve this. How would you solve it though? How would you solve it when what did you learn in the math class? Help with this. What did you learn? How to solve this? Okay. So I'm not trying to like have you invent something new though. I am asking you what you know, but then you need to think in the back of your mind that you will need to teach this to the computer. So, right. So let's do reduction. Reduction and reverse is actually the same thing, right? Inverse and reduction is actually the same thing. So you probably do this, right? You do something like this. So you do this, right? So essentially, it's the same thing as taking the equation and subtract them together, right? You do this, right? Right, this is what you do. So what's the next step though? Can you tell me? What do you transform this guy into? Ref, yes. What do you mean? What do you mean? Can you tell me exactly what you do? You have like row 1, right? R1, R2, R3. What do you do? What do you do? Yes. Some people call it RF. Some people call it row echelon form. Some people call it something. But what exactly did you do though? Whatever the method you tell me. What do you do? Right. Okay. So the goal at the very end, yes, we're gonna see it's 1, 1, 1, and it's gonna become some number, some number, some number, and then you can read it out, right? Okay. So let's do that. That's the goal, right? So to make it into 1, 0, 0, and 0, 1, 0, and 0, 0, 1, 1. So our goal is let's try to make these two guys zeros. Okay, let's try to make that 2, 0. So what you're saying, right, is the following: that R2, right, row number 2 is going to be row number 2, right, minus 2 row number 1. Okay, and row number 3 is row number 3 plus, right, plus 3R1. Right. So remember, we picked this number because we want to make the 0 at the very first term at these people. Okay. Any questions so far though? Any questions so far? So think about this. You will need to teach this to the computer. So there should be no question left. In particular, what I'm asking is the following. How did I get minus 2 and plus 3? How exactly did I get minus 2 and plus 2? Anyone? You guys are awfully quiet today. You ate, right? They give you time to eat already. So okay, so good. So that minus 2 come from this guy minus that guy, and not minus divide that guy. Minus 3 is from this divide by that guy, right? So the factor in front here, let me write it explicitly. The factor in front here is from minus of minus 3 over 1. Okay. Very good. So far so good, everyone. Any questions though? You guys are quite. Where is the initial matrix come from? It came from this. We want to solve this, so we write it as a matrix. Okay. Right. So if you look at this, the matrix multiplication of x, y, and z, right? When you multiply it, it goes down here, and then it's become x, y, z. Add it together, give you 6. Okay. So let's do this. Let's do this. So this will become 1, 1, 1. And you're going to have 0 here, 0 there. And what you're going to get, fix my math, fix my math as well if I do algebra wrong. Okay, 2 minus 2, so that's a 1, minus 2, that's a minus 1. Okay, and so this is 6, right? So minus that, that's not gonna be a minus. Wait. Doesn't matter. Okay. Make sure I did it correctly though. And minus 3, 4, and minus 2. That's gonna be so that's gonna be 7 and 1 and 17, right? Right, you could use the determinant and you can do the adjacent and so on. But you need to write a program to find the determinant anyway. And if you think about it, determinant is actually O(n) cubed. Yeah, but that's a good suggestion. You could do that. You could do that. In some special matrix, it's actually faster to do that. If you know, if matrix has a certain structure, it's actually faster to do the determinant. But yes, it's correct. That's the correct statement. We could do that as well. Okay. So remember, we're gonna do this. We're gonna keep doing this, right? So what we want to do next, right? So what we want to do next is, what should we do after we have this? What should we do? Anyone? What should we do? Then we can do, right, row 3, right, is going to be row 3. Remember, you will need to teach computer how to do this. So that means every decision that you make, you need to be able to explain it to computer, right? Our goal is to get this guy to be 0 now, right? And this is our pivot point, right? Pivot point, let me highlight this. This is your pivot point. Okay, so that means every single factor and every row you pick, you need to know where it is. So I'm gonna have you write it because I think everyone knows how to do this, except you. If you try to write and teach computer, it's gonna take you a while. Okay, row 3 is going to be row 3 minus 7, row 2, and minus 7 come from that 7 over 1, and then there's a minus sign. Okay, so remember, you need to compute this factor as well. Okay, and then it becomes, what does it become though? It becomes 1, 1, 1, and 1 minus 1, and then 0, and minus 7. So that means it's going to be plus 7. So that means it's 8, right? And then this guy is going to be 24 minus 1 and 6. Everyone with me so far though? You guys are awfully quiet. Are you guys with me so far? Yes, okay, with me so far, right? So the next thing that you do, so the process that we have done so far, since we only do 3 by 3, remember we're gonna get a computer to do it like 20 by 20, which you don't want to do it by hands, but you want to make sure that your code works for 3 by 3 first. Okay, so the process that we are doing here is called forward elimination. Okay, it's called forward elimination because your goal is to get it to be upper triangular matrix. So this has to be 0. Okay, and then you need to do the reverse as well. Okay, so I highly recommend you write 2 functions. Don't write only one. Write 2 functions and then call them. Okay, So what we have left to do is to turn this into the row echelon form. I think I called it correctly. I'm not sure, but you want the left-hand side to be identity matrix. Okay, so we're gonna do backward substitution. Okay, so you want to do backward substitution. Right. So we're gonna start by, right? Actually, we skip this step for all along. R3 is maybe we want to normalize it to 1 first, right? R3 over 8, right? It's gonna become 1, 1, 1, 0, 1 minus 1, and 0, 0, 1, and then you can have 3 minus 1 and 6. Okay. So you're all guaranteed that all these are 1. So you want to make sure 2 things. Yeah, doesn't matter. Right? And then you can solve it backward, right? So for example, now you want these 2 people to be 0. You can have R1 and R2 to become R2 plus R3, right? R1 is going to be R1 minus R3, which you're gonna need to figure out where the sign come from and so on. Right, which you're gonna get 1, 1, 0 and 0, 1, 0 and 0, 0, 1, and that's gonna become R2 plus R3. So that's 3, that's a 2, and this is a 3. Okay, and then you do the final step where you take the second row, do it upward, do it backward, right? So R1 gonna be R1 minus R2, which is gonna get you 1, 1, 1, 0, 0, 0, 0, 0, 0, and then it's 1, 2, and 3. Okay, is everyone good? I think you have seen this like 10 times already, and you did it in the homework and so on. Okay, so this is called backward substitution. Okay, and together with the forward elimination, the whole thing is called Gaussian elimination. Okay, any questions though? Any question? So I want you to have this process in your mind when you try to teach computer exactly how to do this. Okay, when you try to teach the computer exactly how to do this. Okay, so let's do it one at a time. Let's do this. Let's write forward elimination together. Okay, let's write forward elimination together. I'm going to give you 2 test samples that what you should return from forward elimination. Okay, so let me switch to my computer real quick. Any questions though about the whole process? I think you have an idea on what to do, but there are going to be some details left that you need to fill in when you actually implement it. Okay. Okay. And like I said, we're gonna do this once in your life, and then for the rest of your life, you're gonna use the library, and then I'm gonna teach you how to use the library. So you can be proud of yourself when you try to solve this. Okay. So our first goal is to do this. There is a way for you to write the matrix. Let me show you how to write a matrix. So A is np dot. A is np dot array, and then you can write in this guy. Oops, sorry. Actually, let me write this. And what do we have here? We have 1, 1, 1. Actually, I recommend you put 1 dot. Otherwise, it's gonna think that it's an int, and it's not gonna work. And then I'm gonna write it's gonna be 2 dot and 3 dot one dot. The dot is to tell that it's a float. So let me show you real quick. So one type of one, that's an int, a type of one dot, that's a float. -3 and 4 and -2. Actually, you can do -3 dot, but the way it figure out the type is that if any one of them is float, so a dot d type give you the type. It's a float. If any one of them is already a float, then you're safe. So that's why I don't need it to here. Okay, and then I need b as well. B is np dot array, and we could call that 6, 11, and -1, and again put the dot in so that I think it's a float. Okay, so the thing that I want you to write is the forward elimination. Okay, you should a and b, and then it should return a prime and b prime. Okay. So this thing should return a prime and b prime. Where a prime and b prime are the thing that you got over here. So that's going to be your a. That's going to be your a prime, and this is going to be your b prime. Okay, and your code, make sure that it works for any dimension. So for example, if you want to know the dimension of a, right, then you can do the following. You can do the following. Let me show you. To save you some writing, the dimension of a is going to be a dot size. Is it? No. It's not size, it's dot what? Dimension. Shape, or not size. There. So this is number of row and number of columns. What is with the dot after the integer? Manit, here's a here's the thing. If it's a 1, then that's an int. If you want it to be float, you put the dot. So actually it's a shorthand for 1.0. It's a shorthand for 1.0. Are we good? So otherwise, let me show you what happens if I do not put the dot. This is going to be what happens. It's going to think that all these three numbers, 6, 11, and -1, are integers. And then when you do b dot d type, data type, oops, it's going to give you that it is an array of int 64, which is not what you want, right? Because int 64, when you do like, you know that you will need to do multiplication and division, a whole bunch of other things. Multiplication is not a problem. The problem is the division. If it thinks that it's does integer division, then you're screwed. It's not integer division, so put the dot in so that you're safe. Okay. Another thing that we can do. So for example, I can say that, okay, can you add row number 2 for me? So A2, so the row number 2 is this guy, right? Row number 2 is A2 plus 2, let's say plus A0. Okay, let's say I add 2 rows and put it in A2. This is how it works. Print A. Right? It does exactly what you think it should do. Okay. That's good. Right? This is gonna save you like at least one for loop. This is gonna save you at least one for loop and make your code looks very easy. Everyone understand what you do, right? Everyone understand what you do, right? So the goal here is I want the forward elimination of A and B. Okay. So I highly recommend you to do the following. Let's call a copy. A. Let's call that little a is a dot copy. So you copy it first. So you know that you're gonna do a whole bunch of replacement like this. So make sure you copy it first. so that you don't mess with the argument. It's just a good practice. Don't change the argument people put in unless it's necessary. Okay, and the rest you do it. I trust you to do it. You have 15 minutes to do it. Make sure it works for any dimension. I'll give you a skeleton then for n row. The goal for the forward elimination, you want to get, yes, that's triangle 0. That triangle 0. Ah, the screen is gone. 2 seconds. Yes, the goal is to get that triangle 0s. Okay. Maybe you need to change something about this, but the idea looks something like this. Okay. At the end, you're going to return A and B. Okay. Where A is an upper triangular matrix. Please do it. Please do it. And ask if you have questions though. This thing may sound easy. Or hard. Depends on what you think. Let me call the pivot row or the anchor row. Let me give you some test sample. Give you some test sample. You should get your A and B. Should be something along, it doesn't have to be exactly this. Should be something along the line of 1, 1, 1. If you do it correctly. 0, 1, and minus 1. And 0. This could be 1. The last row could be 1 if you like. Some people require more than the fact that it's upper triangular. It requires the diagonal to be 1 as well. That works too. And okay. Make sure your code works with any dimension though. If you're done, let me know by raising your hand up. If you're done, let me know by raising your hand. Okay, I'm gonna have you try it first. It's just like programming 1++. Okay. Is there a button to lock my screen so it doesn't go to sleep? Oh, there's no reason. The only reason is because I want it to be 2 characters. You could put it here as well, except it's gonna ruin up all my format. Actually, the fact that exactly one, I only need one number in this array to be float. I just want it to line up nicely, that's all. If I put the dot, then it doesn't line up. Make it 10 minutes. Let me try to do something. You can actually write the whole thing in one line though. There are people who have done it, and he's now very rich. And he's now very rich. He was a student in class and then he has nothing better to do, so he just do this. He tried to write this in one line. Don't do it. Don't take this as a challenge. The pivot row is a follow. The pivot row is, remember the so when you go from you can see my screen on the corner, right? When you go from this one to there, right? You take the first row, and then you get rid of all the zeros on the other rows, right? The row that you use is called a pivot row, right? That's why I loop through that. Are we good? Are we good? So on the first iteration, this row is the pivot row, then your pivot row keep changing, right? Some people call it anchor row, some people call it something. But note how I did not use I and J here. Because you're gonna be confused which one is I and which one is J. If you want to save some writing, then do this. P is pivot and T is target or something. let's write this. Actually, let's do this. Okay, I'll let you figure out the rest. This thing is, the first thing is to normalize the diagonal, normalize the diagonal. You don't really need to do this, but if you do this, then your life is much easier. And once you do this, do not forget to do the same thing for. Oh, okay. Oh, one. Oh, I use little a now, right? So let me use little. Okay, if you're done, let me know by raising your hand. So close yet so far. What happened to the last one? Oh, that's what I meant. Not correct though. It should be 3. What did I screw up? That's the part I want you to write yourself first before you read my code though. Try to write your own first. But I screw up something though. There's something I screw up here. 2 seconds. Let me figure out where I did. This thing should be 17. This thing should be 17, right? 17. Kind of 17. Has to be one byte character off. If you're done, then go figure. Can you help me figure out why is this guy not 17? Has to be one byte off over here. Maybe my matrix is wrong. Wait, why is it minus 2, 5, and 1? Where do we get that? Oh, that's why. I changed my matrix. That is why it doesn't match. Okay, it is already correct. Yes, it's already correct. Okay, let me give you 5 more minutes too. For those of you who haven't finished, let me give you 5 more minutes and then I'll explain my code. Okay. I want you to try it yourself first. You're gonna be so proud. So for those of you who are done, do the other one, the backward substitution. Let me Do you want to see the code? I push it, which I think is correct. So I think I did. Yes, I did push it. Want to see the code? I push it. But I'll give you 5 more minutes and then I'll explain what exactly what did we do. Yeah, for those of you who are done with the forward elimination, do the other one, the backward substitution, and then put them back together and then try to get it to solve like 10 by 10 matrix or 100 by 100. Or you can show who's teaching linear algebra this term though, อาจารย์ Jack or อาจารย์ Pack นะอาจารย์ชัชวาล or อาจารย์ the other one what's his name อาจารย์พรราช or maybe อาจารย์เอก I don't know backwards sub okay A and B Okay, so I think a lot of you gave up already. So let me explain my code. You can see it's actually pretty short and it looks quite easy to understand. You can actually save a whole bunch of lines, but I try to make it most readable. Okay, so here's what we do. Let me put my screen here as well. So we did exactly what we did over here. Actually, let me move this guy a little bit. Let me do this. Okay, that's better. Okay, so we did exactly what we just do, right? So we loop. So the first for loop over here, the first for loop over here, you keep selecting the pivot row, right? Your pivot row, the outer one, your pivot row keep changing. The first iteration, this is your pivot row. The second iteration, this is your pivot row. And the third iteration, this is your pivot row, and so on, right? Your pivot row goes down by one. So when you think about it, you don't really care what it does, but you know that the loop has to go down this way. So this is your for loop, right? And the way that I'm doing it is I made sure that the diagonal element of the pivot row, that thing is one. And I did that by just divided by the diagonal element, right? So far so good. Manit, are we good? Right? I made sure that the element over here is one. Okay. And then for each row, I did exactly what I just said. And then for each row afterward, so this is why the loop looks like this. This is for each row afterward, right? I subtract it so that I eliminate all these rows. Exactly. Exactly. You just loop it backward. Okay. And this is how we did, right? And this is how we did. Range has the third argument, I think, to go backward. Okay, so at the end, you're gonna get a matrix that doesn't look exactly the same as what we did, right? But because I normalize the diagonal to one, this is gonna make your life a lot easier when you do backward elimination, right? The diagonals are already one, so you're safe. Okay, so if you understand that, now do backward substitution and then combine the two. You're gonna be F. F is to normalize the diagonal element. F is to normalize this guy, right? It was 8. I want it to be 1, so I divide the whole thing by 8. I divide that by 8 and divide this by 8. And the reason that I compute it first is because after you change A, this element changes, but you really want the old one. Okay, that's why I assign it first. Okay, now go to backward elimination and put the two together. And if you're done, let me know. If you're done, this is what you can try. This is what you can try. Let me show you. This is what you can try. np.random. Rand, and then you can ask it to do 100 by 100. This is A. Oops. 100, 100. Right, it's for normalizing the diagonal. It's gonna make your life a lot easier. And then before you do that, you do np.seed random. We're gonna learn about what exactly seed does, maybe like next 3 or 4 weeks. But put this thing and then B is A and B. Oops, this is X. This is X. Seeds and the guess I call it X. You can try this A and this B. You can try. your Gauss A and B, and it should be really close to X. Should be really close, not exactly though, should be really close. If you're done with combining the two, and then you're gonna be so proud because you never thought that you're gonna do 100 by 100 by hand, 3 by 3. That's probably what they put in the exam, or maybe 4 by 4 if they are already like very cruel. 5 by 5, no, that's a job for computer. You're not gonna do it. I don't know how range works. Let me check real quick. Just go back up to 0. Nope. Okay, so I need to do this should be all I need. Yeah. The code looks magical, right? Wait until you did whatever you need to do like afterward. It looks even more magical. Most of the code in this class is actually very short if you know what to do. I think something else. This is it. Yay. Yes, very close. Everything is very close. You see, you can solve 100 by 100 matrix equation within 71 milliseconds, and you didn't even bother to optimize this. In C, it's probably take nanosecond. Or maybe something close, maybe microsecond. C is typically about 1,000 times faster than Python on a typical case. But the development time may be also 1,000 times slower in C as well. Okay. If you are done with the Gaussian elimination, let me know by raising your hand. By raising your hand. Let me push this thing on GitHub. Okay. If you're done, let me know. This is quite a complicated code, but it's actually short. But to think about what you need to do is actually hard. And also think about what's the complexity. For those of you who take data structure already, I know some of you haven't taken data structure yet. For those of you who know what a big O is, what's the complexity, time complexity of this guy? What's the time complexity of this? Okay, think about the code that you just wrote. What's the time complexity of this guy? Should be pretty obvious. Might be done cannot like second homework. No, not n square, not n square. Be careful, be careful. Not n, not n, not what m by n. What's m? You only have n, right? A has to be, A has to be n by n matrix. So A is n by n matrix. What's the big O? Complexity or big O of what? Someone tell me. I know at least one of you can figure it out. Just read your code. Just read your code. Just read your code. You're gonna see. N square is close, but not quite. Be careful. And you guess n log n. No, typically n log n comes from the fact that you do some sort of divide and conquer. We did not do divide and conquer here. We just have for loops. It's not n square though, because we hit a lot of complexity somewhere. Very good. O n cube, right? Because you have two for loop. This thing run above n, and this thing is also n, right? It's actually n square over 2, but you don't really care. So this is n. That's another n. And also you need to subtract every single one of them in a row. So that's n cube. Okay. So to solve linear equation, you can do, this is actually one of the best n cube in general, unless you know some structure of the matrix, then you can simplify it by a lot. Okay, if you know some matrix structure, then you can simplify it by a lot. Right? N cube is something you should be scared of. In real life, typically, unless you have like infinite computing power, you aim for n or n log n if you can, n squared and n cubed. You need to warn the user to wait a little bit, but in this case, it's just 100 by 100 is nothing, right? It takes like millisecond. You can try 1,000 by 1,000. This is a million number, by the way. Don't go too crazy. It's a square. Right? 5 seconds to solve 1,000 linear equations simultaneously. Which is still pretty fast. We're gonna learn next time how do we solve this kind of thing in general. We may not get the right answer, but we are fast. Okay. Any questions so far though? Is everyone done? If you're done, please raise your hand so I know. Because if we are in actual class, I walk to you and I can see if you're done or not. Okay. So I think we learn one more task. We learn how to get the computer to do one more task, which is solving linear equation. And it's actually surprisingly very common that at the end, whatever you do, you're gonna need to solve system of linear equations. Okay, and we're gonna see one task today, which is one of a very important tasks to do. Okay, we're gonna see one task today. Okay, please do it. Please do it. Yes, I don't know. I don't know. I think this thing is really cool, right? You get computer to do something you never thought it can do before. Okay. But I want to show you another thing as well. Okay. This is how they do it in real life. For a code that is like highly optimized, this is what you do. You have np.linearalgebra.solve, and then you put in A and B. Oops. ALG.solve A and B. See, they do it in a much faster way because they do it in a much faster way. Yeah, this is what you do in real life. This is like real life. Real life. Do this. Much faster because they know how the CPU instruction works, how the RAM works, and so on, which you might learn in system skill, which a lot of you are taking. This is cool kids. Let's do this. Cool kids, write your own Gaussian elimination. But real life, you do this. You don't write your own, but inside it does something very similar. But they do it in a much more optimized way. Like they do it in C. So for example, this loop, they do it in C. They do this loop in C as well. So at least counting the index in Python is slow. Okay, if you're done, please raise your hand so I know that you are still with me. So the rest you may give up already. Yeah, I push the code. Yeah. So I don't know what you guys are doing. I already pushed my code. And any questions before we go on to do something really cool next? Okay, so let's do this. If no question, I don't know why there's no question. Okay, so let me switch the screen real quick. Switch the screen. Hey, OBS, where are you? Okay. Okay. So guys, listen to this one carefully. Listen to that sound carefully. This is very important. Okay. It's going to be very useful to you guys. Okay. Especially for risky. This is the trick that all physicists needs to know. Okay. So here's a problem. Here's a problem. Like I said earlier, right? Like I said earlier, we have the data point. I don't know. You could do what? The weight and the height. Okay. Let's say the height and the weight. Okay. Right. Least square fitting. Let me get rid of this. That. Okay. So what you do is the following, right? You go collect the data. You go collect the data. And then you found that the weight and the height look something like this. Okay. Our eyes can see and tell right away that this is the trend. Right? Now this is a trend, or you might have done it in physics lab already, that you do whatever that's called least square fit, whatever Excel is doing, right? It gives you that line like magically. It gives you the slope and intercept like magically. Okay, so what we're gonna learn today is to figure out how exactly did you get that line. Okay, to get that line, we need to know one thing. What's the difference between the good line and the bad line? So let me draw one bad line. Okay, this is a bad line. Clearly, it doesn't pass through anything. This is a bad line. Okay, what's the difference? Can anyone tell me what's the difference? What's the difference between good line and bad lines? The margin. What exactly do you mean by the margin? What do you mean by the margin? What exactly is a margin? Can you tell me? You're on the right track, but what exactly is a margin? Margin of error? Margin of error. Well, how do you measure it though? How do you measure it exactly? Let me call this thing. Distance between point and line. Very good. So this is good guess, right? And this is a bad guess. Okay. So like Adil was suggesting, right? A good line, right? A good line is the line that is close to the points, right? So a good line looks like this. A terrible line is a line where the point, oops, where the point and the actual line that you guess, that means your guess and the actual result are so far off, right? So we learned one very important concept. I want everyone to see this. We will start with a physical intuition, right? We're gonna start with a physical interpretation of what it means to be a good and bad. And then we are gonna formulate it mathematically to see how we're gonna throw it to the computer and solve for you, right? Because right now you cannot tell the computer, okay, find me the line that give you like the closest distance and whatever. You can't do that, right? You need to do some math and tell the computer to compute something for you. Okay, so far so good. The good line is the line that's close to the point, and the bad line is the line that's far away from the point. So, which means we need to compute the distance between the line and the point. Okay. Can we just draw a bunch of lines and find it close? That's actually a brute force way to do it. But no, we're not going to do that. We're going to do something a lot smarter. You're going to see. We're going to do something a lot smarter. Right? that was not a bad idea, right? If you try to find the maximum, why not just randomly draw a whole bunch of lines and compute? But we know something better, okay? So to be able to compute it, right? To be able to compute it. So let me call this X and let's call this Y in general, okay? So to compute the distance between the point and the line, we need to know what a line looks like first. We need to know what a line looks like. What is a line? Can someone tell me? What's the equation for the line? What is an equation for the line? There are actually like 10 ways to do it. Pick one. Give me one. Give me the one I want as well. What is a line? Very good. Y. Let me call A and B. Let me call A and B, not M and C. Y is A, X plus B. Right? So far so good? So the other line, the difference here, don't call me. The difference here is the following, right? If you have another line, right? The difference here is that this line gonna have different A and B, right? Someone get, right? Different line, different A and different B. Different lines, different A and B. So that means what we are doing in choosing a line, exactly what we are doing is we are picking the A and B, right? So this is very important. Choose the line. It's exactly the same question as choose A and B, right? So that's good. So our game is actually to find what's the best A and what's the best B. Okay, and we have a vague idea of what the best mean. The best in this case kind of mean that, okay, whatever you guess, it has to be close to the actual data. Okay, everyone with me so far? Any questions so far or any question? Okay, before we delve into a whole bunch of math. Okay, so the goal here is to pick A and B, but we want to pick it such that it's closest to the data. Okay, so let me do this. Let me do this. Okay, I'm gonna put here as well. Y guess. Y guess, because this is what you guess, right? Y line. Okay, and each data point I'm gonna call X I Y I. So you X I Y I, right? So you can call this thing X0, Y0. This thing gonna be X1, Y1, and X2, Y2. I put it in this. Okay, so far so good. So the idea here is you have a bunch of data points, okay, and you have a line. You want to compute the distance between the point and the line. What would you do? What do you do? Physically, what do you do? How do we find this distance, that distance over here? What is it equal to? The coefficient, what coefficient? The distance between the point and the line. How do we compute it? How do we compute it? Anyone? We are not picking any y, right? We are picking y at very particular point. At very particular point to compare. But how do we compute it though? What should I put there? What is it equal to? Let's think about this. If this guy is x5, y5, how do you compute that distance? How do you compute that distance? Anyone? How do you compute the distance? It's not exactly y, right? Salan suggests y, but it's not exactly y. It's something else. Very close to y, but not y. How do I know how far off this guy is from that guy? What do I do? Ax plus b. Combine the two answer, and then you're gonna see. Combine the two answer. You're so close, but not quite. Salan, you're so close. Combine the answer that you gave me. How do you compute it though? How do you compute it? Can you tell me physically, like how would you compute one? Everyone can see, right? We want this distance. Or maybe you guys are tired from data structure. What did Ajahn Kanat do to you today? What did he do to you today? Why you guys are so quiet? Okay, so let me tell you, he did a Gradle. Okay, so let me tell you. So here's what you do, right? You take the y from the point, right? The y from the point that you're interested in, minus the y that you guess. Okay, and it's not any y, right? Y guess is a function of x. So you're taking the guess at x of the point. Can anyone see though? Can everyone see? That's like how far off they are from each other. You subtract the two, right? Any questions so far though? Any questions so far? Right? Y guess is the above, the thing below. If you want to see the difference, you subtract the two. That's basically what it is. Okay. Any questions so far though? Any questions so far? Yes, right. We don't have Y guess yet. Y guess depends on A and B. Right, but if we know how to guess, given A and B, if we can score it, we're gonna find the best one. Any questions so far though? Any question? This is very important point. It's not a function minus a point. This is a number. Given A and B, this is a number. Right? Given A and B, this is a number. So that Y guess is a function of X and is parameterized by A and B. Okay. Any questions so far though? Any questions so far? This is a very important point. So if no question, let me ask you. What you wrote over here, yes, it is a distance between the point and the line. Yes. But when you try to say, to give a score to something, whether it's a good or bad, you want one number, right? You really want one number. But if you think about it, for each data point, you have the distance. Each data point, you have the distance. So how do you combine them into one number? Right? You're gonna have a whole bunch of distance. You're gonna have a whole bunch of distance. Okay. So Saran suggests maybe we could do the following, Ajahn. We could just find the average, which is exactly the same thing as the sum. I keep putting I somewhere else. Okay. So we could do this. But Risky, why did you suggest the absolute? Why did you suggest the absolute? What's wrong? What's wrong with what Saran was suggesting? Why did you suggest the absolute? What's wrong with just adding them together? Very good. Because the thing that is above the line and below the line, they should not cancel out, right? One of them is going to be positive and the other one is going to be negative, but both of them are bad. Doesn't matter if you're far away above or if you're far away below. They are both really bad. So you have the choice. The first one is the absolute. What's the second choice? Absolute is bad because it's not differentiable. Can you give me something differentiable? So it's the square, right? So we're gonna call this our score, or some people call it the cost function. Okay, so the cost function is nothing but the sum of the distance square from our guess to the actual point. Okay, so far so good. So what do we want though? What do we want the cost function to do? Do we want it to be low or do we want it to be high? This number, the sum of distance square, do we want it to be high or do we want it to be low? We want it to be as low as possible, right? Everyone agree on that. We want this guy to be as low as possible. We want it to be low. We want to minimize this. Okay. But what can we change though? What is it on the right hand side that we can change? Let me make it a little bit cleaner. Sorry about that. Let me just draw it. What can we adjust though on the right hand side? What can we adjust on the right hand side? When we say minimize, right, it typically means you compare it among a whole bunch of other things. So the question is, what's the difference between the one you have and a whole bunch of other things? What's the difference among them that you want to compare? So that means what can you adjust when you try to minimize this? What can you adjust? Y guess? How do you adjust Y guess exactly though? If you constrain it to be a line, how do you adjust Y guess? With A and B, right? A and B are the numbers that you can adjust. Okay? A and B is are the number that you can adjust. Okay? This is very important point. So to find the line, to find the best line, is this exactly the same question as minimize the cost function by adjusting A and B? Are we good? Okay. Now that sounds more like a mathematical statement that we can get computer to do, right? Okay. This is like the first of the series on how to minimize things. Is everyone good with me though? Is everyone good with me? Okay. That the question of finding the best line is exactly the same question of finding the best A and B. Okay, so let me write that. Let me write that real quick. Let me write that real quick. So the cost function, right, is sum. Some people divide that by n, sum over all the data point, the actual data point. Actually, let's do it the other way. It's square, so it doesn't matter, right? Y guess at xi given parameter a and b minus yi and then square. Okay, and let me expand it. Let me expand it. So the way we get y guess is a xi plus b minus yi square. This is the cost. And our goal is to find a and b that minimize the cost. Question. If I change this to 1 over 10 or 1 over 100, does it change A and B that give you the minimum? That's a very good question though. Okay. What do you think, Saran? What do you think? If I say cost, if I put 1 over 100 over here, Does it change the value of A and B that give you the minimum? What do you think? What do you think? What do you think? Could be why? Think about this. If I call this like you give me a wallet with 100 baht and 100 USD, and then I ask you to find a wallet with the most money, it's gonna be the same wallet, right? Doesn't matter what kind of unit you say you compute it in. You can compute it in like the Japanese yen. You can compute it in Thai baht. If points make a curve, there is no curve. There is only a line. You fix A and B already, right? You just scale down everything by a factor of 100. You did not change the person that has the best value. Are we good? Are we good, Saran? So that means dividing or multiplying a constant or adding a constant doesn't change the location of the minimum. So what we care about is not the value of the cost function. What we care about is the value of A and B, because that's why it makes an excellent question, right? You could divide this by 100. That doesn't change that A and B gonna, the place that A and B give you the best value, right? Or you could add 5 to everyone, right? You could add 5 to everyone. It doesn't change the value of A and B, right? You could add 5 to every A and B. Okay? So far, so good? Sharan, are we good? Let me move this a little bit and let me make it more explicit. Let me make it more explicit that this cost function is a function of A and B. Sharan, are you happy though? That's a very good question. And if you understand that, then you get. But you fix X and Y already, right? You fix X and Y and then you try to find a straight line. Yes, your X and Y could curve all you like, could do this if you like. But if your model, you restrict it to a straight line, you're gonna draw this, right? If you only have Y equals AX plus B, you would only have a straight line. If you try to do something more complicated, which we're gonna do later, then you're gonna get that curve. But if you fix it for A and B, right? The question is to fix it for A and B. X and Y are fixed. This is your data point. You cannot change it, right? You cannot make up the data point, not like people who do N equal to 2 with the vaccine. You cannot change the data point. Okay? The data point is fixed. You're trying to find the line. The sample could increase if you want, but that's the different question, right? Given a fixed sample, the A and B that gives you the best value never change. Okay? Given a fixed X and Y. Okay? Okay. So I think everyone understand that. Any question though? Any question before we do the real math? Any question? Everyone understand, right? We transform physical problem into some like optimization problem, right? We transform a physical problem into optimization problem. And now that means what we are left to solve is an optimization problem of finding A and B. Anyone has a good idea though? How do we find the optimum point of anything? Of anything? What did you learn in math? What did you learn? How do you find the optimum point of anything? Well, so far that you know. What do you think, guys? What do you think? Finding the maxima equal to 0? Very good, Risky. Okay, now I'm proud. You learned something from physics. Right, so that means all we need to do, right, is to solve two equations. It's to solve two equations. That means we learn how to find the maximum, right? Differentiate, set it equal to 0. That's all you did. And that's the most important lesson in calculus that you should know. That's the most important lesson in calculus that you should know. that to find the extremum of anything, the derivative has to be 0. And in this case, it's two variable, right? So the gradient has to be 0, but close enough. You're gonna see how powerful this is. This technique used like in, if you think about it, every single problem is an optimization problem. Like what to eat for lunch, that's also an optimization problem, except the cost function is unclear. Okay, so we're gonna differentiate this by A, and we're gonna differentiate this by B, and gonna set it equal to 0. Are we good? That's what we are gonna do. To find the maximum, to find the minimum of something, you can actually show that this guy only have the minimum, doesn't have the maximum. Okay, you differentiate it and set it equal to 0. That's easy, right? That's easy. That's easy. That is easy because we want to find the thing that minimizes the cost. Next time we're gonna learn like a more general technique on how to do optimization, but this time let's do something cool that you learn from calculus. Okay, so let's differentiate this. Okay, let me write down everything. Let's differentiate this together. Sum over I, AXI plus B. Now you see why I put AXI plus B first. So that you do not have the nasty minus sign that you need to work around. Okay. Now you see another problem. Ajahn is the derivative of the sum. What do you do? What do you do? What do you think we should do? What do you think you should do? Anyone help me do this? Right? The thing is, these two guys, what should I do with the two? Derivative of the sum. What do you know? What do you know? What do you know? What do you know about it? Risky, tell me, as a physicist, what do we do? What do we do? Derivative and the sum. You don't need to prove it, but what's your gut feeling? Tell me your gut feeling. Typically, I taught you in discrete math, right? You need to prove it. You need to prove it and so on. No. Typically, in real life, you guess. It should work this way, and then you try until you get into some trouble. And then you leave it the proof to some mathematicians. Okay, that's the real life. You guess it should work this way, and then you try until you get into trouble. Anyone? What do you do? What do you do? The derivative of the sum. Let me remind you some calculus. Let me remind you some fact on calculus. Sum, right? The sum is nothing but like x, y plus y plus c, right? What do you do? What do you do? What do you do? Just watch or just switch? Switch. Right. So you can distribute this guy in, right? So this is exactly the same thing as right? Or that means the sum of the derivative is the derivative of the sum. Or derivative of the sum is also the sum of the derivative because it's linear, right? So this thing is a sum over I d by dA, AXI plus B minus YI, and then square. You can actually prove it though, but right, you guess it. You should be able to switch it, but the thing that back it up is this: the fact that you can put the derivative, you can expand the derivative. The fact that you can distribute the derivative. Okay, is everyone good? Everyone good, right? Okay. So one thing you learned today: derivative of the sum is the sum of derivative. So yes, you can switch them. You can switch this. Even the sum, sum and integral is the same thing. You can actually switch them inside the integral as well. Except for some really rare case, which we're not going to talk about. Except for some really rare case. Okay, so that means the rest is just doing normal calculus, right? You need to help me on this one. You need to help me on this one. So we have sum over I. D by D. How do I take derivative of this? Can anyone tell me? Anyone tell me? What do you get? How do you take derivative of this guy? How do you do the thing in the red parenthesis? What do I have? The first thing that I should write is what? What should I write? Anyone? Help me on this one. Can you guys help me on this? Very good. Thank you, Risky. So you have 2, right? You pull down the 2 and you left with whatever the chain rule gives you, plus b minus yi, right? But then you need to take derivative of the ax plus b plus yi, but the rest are 0, so you have left with xi. Okay, is everyone good? Is everyone good though? You still remember something from calculus, right? Like how to take derivative and so on. Okay. So let me simplify this. Let me simplify this a little bit. Let me simplify this a little bit. This is 0. This is 0. So 0 is going to be, I'm going to simplify it a little bit. It's 2. Because it's equal to 0, right? I can just pull the 2 outside the sum and then cancel it with that one. I can divide by 2 both ways. So let's get rid of that. That's like annoying. Okay. So that becomes a, the sum of xi squared, right? Plus the sum over I of b minus the sum over I of yi xi. Okay. Actually, let me write this way because I think we haven't got to that. So that's a good, right? But a and b has nothing to do with I. A and b has nothing to do with I, right? So that means what you got, let me just copy this real quick. Any questions so far, though? Any questions so far? I want to make sure that you follow this math because you need to do as an exercise something a little bit harder than this. Okay, so you can do the following, right? You know a has nothing to do with the sum, so you can throw it out. Okay, so it's going to be a sum of xi squared. Okay, plus the sum of b. What do you get? What do you get? You add b up. The number of times that you have the data point, what do you have? If you have n data points, what do you have? Let me put here. What do you have here? What do you get here? Guys, what do you have? Wait, actually, I forgot one thing, right? Oh, I forgot to multiply by b. Ah, sorry. Right, then I can do the same thing, right? And that is equal to minus the sum of yi xi. I screw up one thing. There should be an xi here because I multiply xi inside. Not n over 2. No, you're not summing over I, Saran. You do something much easier. Is everyone good? Is everyone good? Once we got here, is everyone good though? Is everyone good? The fact that we have it here. Yes, it looks scary, but if you think about it, it's not that scary. If you think about it, it's not that scary. Any questions so far though? Any questions so far? How we get this? Any question? If not, let me ask you, what are the variables and what is a constant? Okay, right? Even though I call these things x and y, they're not variable. They are data points, right? Which is fixed. So if you think about it, this guy is a number, right? If you have all the data points, it's very easy. You sum of all the x square. That's all you need to do. And also this guy is also a number, right? Like 10, 5, 12 by 2. Okay. And this guy is also a number. Are we good? Right? Even though it looks scary, this equation is exactly the same thing as like 5a plus 3b minus 2. Okay, even though it looks scary with a whole bunch of sum, but the sum is is just the sum. You have know the numbers already. Okay, once you know the number already, there's nothing to do. Like you just sum it up and it's a number. Okay, so that's one of them. Okay, so let's leave this. Let's call this number 1. Okay, let's go do the same thing for b. Okay, let's go do the same thing for b. So we want to do d by db of the cost function, and it has to be equal to 0, right? So that would mean it's going to be d by db of the sum, the sum of axi plus b minus yi squared. Okay, help me do this. What is it equal to? What is it equal to? Anyone? What do you do with the derivative and the sum? What do you do? What do you do with the derivative and sum? Are you guys with me so far, though? You guys are awfully quiet. Distribute. Okay, that also means switch, right? The sum over I d by db of axi plus b minus yi, and then square. And that is something very easy, right? You can do it. It's going to be 2axi plus b minus yi. And d by db of b, it gives you 1. So multiply that by 1. Okay. And let me simplify, collect things together, right? And you know that the 2 is gone, right? Because this thing is equal to 0, so the 2 is gone. So the 2 is gone. So it is going to be the sum of xi, okay, plus the sum of b plus the sum of yi. Okay, can someone help me simplify this guy? You add b up n times, what do you get? Close, n times b, not n, but n times b, right? You add b up n times, you get n times b. Yeah, so far so good. And like I said before, this thing looks scary. It has an x, but x is not a variable. X is a constant, right? X is your data. That also is a number. This is also a number. So these two guys, okay? So these two guys are actually just two linear equations, right? These two guys are actually just linear equation. Can everyone see it still? Right? I haven't rearranged it, but I want you to see in the back of your mind that, okay, Ajahn, the top one is nothing more than just 3a plus 2b minus 5 equal to 0. And the bottom one is maybe 10a plus 20b plus 10 is equal to 0, right? So these two are nothing but just a linear equations. Are we good? Are we good, right? Remember, we went a really long way. We start the question of trying to find the best line. Then we turn that into an optimization problem, right? That we write the cost function that sort of do what we want. And then what we do is we use calculus to turn it into a linear equation. And now we're going to throw a linear equation to the computer to solve for it. Everyone with me so far, though? Everyone with me so far? So let me copy this. Any questions, though? You guys are awfully quiet. I'm afraid that you don't get it because you will need to do something very similar to this. Don't get? You enjoy watching this? Okay, good. Anyone has any question, though? I'm afraid that I went too fast and I lost like most of you. Even though video is there for you to rewatch, but I kind of want you to get it in class so you don't have to rewatch it. Okay, so let me copy the two equations and then we're gonna write as a matrix. Okay, this is number one. And this guy is number two. So you can, okay, so let me do this. Let me clean this thing up a little bit. Clean. Okay, now we try to write this as a matrix, right? So the first, did I screw up the sign? I did, thank you. Oh God, check my algebra though before I screw up. That thing should be minus. Yeah, that thing should be minus. Just copy it from here. Okay. Okay, so the first thing that we do, right? Remember when you see like sum of x and y, it is a number, nothing scary. Okay, so I claim that this you can write as a matrix and it looks like a very nice matrix as well. A and B. This is two variable, right? So you see. And then and yep. And this has a name. It is called the normal equation. Actually, normal equation is actually the inverse of this, but you get the idea. Okay, can everyone see this though? So now you have a clear method on how to find A and B, right? If you have the data, all you need to do is, okay, fill out the matrix on the left, which is just a whole bunch, it's just 4 numbers, right? Fill out the matrix on the left, actually 3 numbers because the 2 are duplicate, but it's just a number. This is like numbers. This on the right is also numbers. And this is what you want to find. Right? So far, so good? Any questions so far though? Any questions so far? We're at the end though, and then we're gonna go do the exercise. You can actually make the magic happen. Any questions so far? Any questions so far? Are you confident that you can get this to computer and computer gonna do it for you? Actually, it's actually pretty easy. Anyone? Okay. If no question, any questions though? Or you are lost already and you want me to review that? That works too. Or you gave up on your life already? I think I did something to you like earlier today, right? Next time, I'm not gonna put the class on the same day as a Dankanat's class. Okay, so let's do this. We have a whole bunch of things to do. So let's do the following. What's the difference between equation 1 and equation 2? Equation 1 comes from d by dA. And equation 2 comes from d by dB equal to 0. Okay, but you need the two. They are totally different things. You need the two, right? Think about it. You have two unknowns, right? A and B. You need two equations. So this is how you get the two equation derivative of each of the variable, guaranteed to give you at least one. Okay. So let's do this. Let me switch to this guy, that guy, and let me move this away. Let me move this away. And what is wrong with my CSS? Okay, that's better. Okay, so here is the data I have for you. Okay, the data X and data Y. And if you plot it, right, by now you are expert in plotting it. And then I ask you to find the line. By eyes, you know clearly it has to be the line in the middle, right? So what I want you to do is get this line for me. Get this line for me. Okay, find A and B and make this plot. And tell me what you got. Find that red line for me. Okay. And this is all you need. It could be maybe like 10 lines. That looks very magical. It should give you A and B. Find that line and plot for me. of the best lie, that would be, you want to compute that matrix. Easier if you compute function S. Let's do this. And there. How many lines? It's like 10 lines. You can actually make it like shorter. If you're done, let me know. If you cut this graph, then I'm happy. Back. Okay. If you cut this graph, let me know. Okay, I recommend you to fill out the exercise after class though to make sure that you actually understand what we are doing, or feel it during class works too. If you do it right, your A and B should be around these two numbers. If you get the graph, raise your hand and let me know. Done. Good job. Right? You can see this is nothing short of magic, like 10 lines of magical code. Okay, if you're done, let me know. Let me know. Because I want to teach you even more cool things. And this is what Excel does. There's also the error, which is a long story. The error on the slope is a long story. Okay, if you're done, let me know. I want to teach you something even cooler. So for those of you who are done, this is your next challenge. Fit this parabola. Fit this parabola. You know, you want the red line in the middle, right? I'm going to talk about what to do, but after a certain number of people has done. But you can go think about it first. How would you fit a parabola? Okay. The technique that you just learned, It's not restricted to just linear functions. The word linear regression is actually not linear in X. It's actually linear in the parameters. Yeah, go figure out how to do the parabola once you're done with this. Next week, we're gonna learn a more general technique on how to do this, and then that thing actually opens your world by a lot. What we learn next week is gonna open your toolbox to like a whole vast amount of problem, which you're gonna see in the homework. That the problem you're gonna see in the homework is like very random. Okay. By the way, do the homework, please. Do the homework, please. I know you have a lot of work, but my work is your work as well. So please do it. We also have TA for this class, but no one scream on Discord, so the TA doesn't have anything to do. So if you have question about homework, just scream on Discord. Someone's gonna come and help you. Okay. Like I said, the homework is not like the place where I measure how smart you are and so on. It is a place I want you to learn. Okay, so please learn from the homework. If you struggle on the homework, then scream. Someone's gonna come and help you. Okay, if you're done, let me know. Just put these two equations in and then you're done. Nothing more fancy than that. But to get these two equations, then you need to understand some math. Okay, try do the parabola by yourself first. For those of you who are done, you're gonna be so proud of yourself of discovering something really new. And then you're gonna find that it's very similar to what we did over here. You modify it by one line, that's all. You modify it one line, that's all. Or maybe two lines, one or two lines. So if you're done, go do the parabola. Go figure out the parabola. Parabola, by the way, is ax squared plus bx. Let's see. That's why I taught a, b, and c, not m and c in the beginning. You only need to modify two lines, but do the math and then you can see you need to modify two lines. Or maybe three, less than 10 lines that you need to modify because the code is only 10 lines. So if you're stuck, let me know as well. Yeah, then try the parabola. If you occupy for a while and then you figure out that there are like two lines that you need to change. Go repeat exactly the same exercise by taking derivative by A, taking derivative by B, taking derivative by C, and then you will see what you need. Okay. So are you guys still trying the rest of you? Or you gave up already? Okay, so for parabola, a lot of people gave up already. Okay. Can show you. At the end, this thing gonna work. I'm gonna look like a match. And there. Where are you? Show me your code, Justin. I can kind of guess what happened, but show me your code. Put it on Discord or something. If it's a picture, I don't think you can put a picture on Zoom. Then I'll have there. See, for those of you who are done, get the parabola. Just impose your code on Discord so I know. Let me get the Discord open. A lot of people say that it's the same as my code. 2 seconds. Why is Discord like disliking me? Okay, and what happened? I have 16 gigabytes of RAM. I should be able to click anything. What? No, show me the code, not the output. Oh, that's the code. XS. Print A and print B, and then you're gonna see. Print A and print B. A and B should be a number. I don't think it's a number. Your little A and B should not are not numbers. There, your A and B are not numbers. You should return numbers for A and B, right? Your A and B over here are some sort of matrix, which is not what you want. You just want the number. You probably want this guy though, but A and B should not be that big. What? Wait, which one is which? But again, A and B should be number. This is not number. I think it's the last one maybe. Right. You returned the wrong thing. Your Gaussian elimination returns the wrong thing. I return only the last matrix though. That's why I can do this. N-O-N-Q. After you do this a while, you're gonna see there's a pattern. Yes, your A and B are not correct. You return two arrays from the Gaussian elimination while you should just return one. right? Gaussian elimination just return the value. You probably return the capital A and B over here. I just return only B over here. Because this is the solution. I know A is an identity matrix by now. Or you can just do this. You can just do this as well, Justin. Like I said, you write Gaussian elimination one time in your life, and then you do np.linear algebra dot solve, and that works too. It gave you exactly the same answer. And then go fix your Gaussian elimination, but it's one line fix. You can do it. Okay, everyone get the parabola, right? Anyone got the parabola? Let me got the hands down. Do you guys get the parabola? Good job, when you got the parabola. Adil got the parabola? Which one? That one. I actually push it to the GitHub, though. You can look at GitHub if you want to scroll. So Risky, I think at least one of the big mystery in your life is gone, right? How does Excel get the line for you in the lab? And this is exactly how. Okay, the uncertainty, that's another big mystery that requires a lot more math. The uncertainty on the slope and the uncertainty on the intercept is another big mystery. I have a write-up on it though. I taught some people that need to know on a need to know basis because it's actually quite complicated. But next week we're gonna do something even cooler, even more generic than this. Okay, so I think we are starting to run out of time. I need 1 hour to teach you some more cool things. Okay. So let's look at this, guys. So sorry about that for those of you who are not done yet. I pushed it on the GitHub already. Okay, so here's what we want to do. Here's what we want to do. So remember what we did, right? We do like y equals to mx plus c. That's one dimension. That's boring. A whole bunch of things in the world, they are not one dimension. They are multiple dimensions. So for example, the height of the child, right? If let's say you have a dad and a mother, right? And the child eventually she's going to grow to some height, right? And that is some linear combination. Let's say that by some biological knowledge, we know it's some linear combination between the dad and the mom, right? And maybe some offset because you are the next generation, you have better food and so on. So we could guess that the height of the child depends on at least two variables. There's nothing stopping you at two though, right? There's nothing stopping you at two. So for example, you could plot the following. You could make the following plot. It could depend on a whole bunch of other factors, but all we need to do is figure out all the coefficients in front, right? C mom, C dad, and H0. But let's plot this. Right? So father and child, they have some correlation. And the mother and the child. Wait, I have better keyboard. Why do I keep typing on this one? Oops. Okay, so father and the child, not much, but the mother and the child shows you some really nice correlation, right? But you want to predict the height of the child based on the height of the mom and the height of the dad. So you want to be able to figure out all these coefficients, right? And we learned earlier that a good C mom, C dad, and H are the one that give you a good guess for the child height, right? So you could repeat the same exercise again, right? You could repeat exactly the same exercise again to get all the C and H0, right? So that's what we're gonna do, okay? So that's what we're gonna do. So let me switch that real quick. Let me do the math for this one really quickly to show you that there's nothing stopping you from doing multiple variable, and this is actually a more generic approach. Okay, so for example, we guess, right? So our cost function is going to look exactly the same. It's going to be the sum over all the data points or whatever you guess. Okay, whatever you guess, which is you can actually write it as a vector and it looks nicer, but let's not do it. So it's going to be C mom times mom's height. So let's call it X mom. Let's multiply that by M. This is the mom plus CD times the dad plus S0, right? Minus C of the child, I, right? Mom, I, and dad, I. Okay, and then square, right? So once we get the cost function that looks like exactly this, this is your guess, right? I think everyone can see. This is your guess. This is the actual data. You want the function, the two function to be as close as possible, right? You sum this. So that means all the thing that you need to do is now just take derivative of this guy by the mom, just take derivative of this guy by the dad, just take derivative of this guy by H0. Okay, and set it equal to 0. And by now you're an expert, right? So let me do that real quick. Let me do that real quick. So this time it's going to be the sum of I, and then d by dcm, that's become 2 cm mi plus cd di plus h0 minus cci, and then multiply that by mi, right? So that becomes, you get rid of 2, so that becomes cm, the sum of mi, right? And then cd, the sum of mi squared, the sum of di mi, okay? Plus h0, the sum of mi minus the sum of CCI and MI. Okay, which looks very close to what you have, right? So for that, you can guess it's almost the same thing, right? Let me just write it for that. It's gonna be the sum over mom and that. I'm gonna leave out the I because you get the idea. CD, the sum of that square plus H0, the sum of that minus the sum of CCI that I, right? And by H0, that's the same idea. That's the same idea. So that becomes C mom and sum over mom plus CD sum over that plus H0 times N minus the sum of CCI and then times 1. Okay. So that means you can write all these as an equation, right? I trust me, I take derivative correctly, but this one is easy enough for me not to screw up. Maybe I did screw up, I don't know. Okay, so that means all you need to do is write these three guys as a matrix equation, like we did last time. So let's copy this and paste this. Let me just write it in terms of matrix equation so you can throw it to the computer and the computer can solve it for you. So that means it's going to be the sum of mom square, the sum of dad and mom, the sum of dad and mom, the sum of dad square, and the sum of mom alone, the sum of dad alone, the sum of mom, sum of dad, sum of, not the sum of anything, just n, right? Multiply this by, what is this? Multiply this by Cm, C dad, and H0, and it has to be the sum of CCM and the sum of CCD, the sum of CC. Okay, and that takes you 5 minutes to do it. Okay, so that means this is the same deal as what we did for parabola and for the linear. That means all you need to do is construct this matrix, and then you're done. Because you can throw it to the computer to solve for it. Okay, so let's do that real quick. Let's do that real quick as well. Right. So what I show you is actually a very powerful technique. Can you do actually if you write this as like variable, right? If you do this as a variable, then you're gonna see that you're gonna see a pattern that this guy come from the fact that there's one m from here, right? And one so yes, there is an easy way to do this. Okay, but you're gonna see the pattern that there's a sum over m squared that's come from itself, multiplied by itself, right? If you have 10 equations, then that's the same thing. If you have 10 variables, that's just exactly the same idea. You're gonna see a pattern if you do this enough time, right? So it's gonna look like this guy, except for this guy, this thing has the offset. The rest gonna look like this. If you have 10 variables, it's gonna look like this all the way. Okay? So yes, we can capture the pattern and make it do generic one. But next time we're gonna do something a bit easier to write, but much slower. Okay, so let's do this real quick. Let's do this real quick. So let me switch to my this. Where is the full screen? There. Okay. So let's see the best. Let's say best per round. Then we put in all the data, right? So the mom height, M and D, mom, dad, and child. Okay. So we want the what? Actually, it's easier to do this. N is np.sum. This is assigned as a function, and then A is np.array, and I need 3 of them, right? S, so this guy is m squared, S d times m, and Sm, S d times m, S d squared, SD, Sm, SD, and let's call this length of m. That works too. Right, and B is np.array. B S of C times M, S of C times D, okay. You can actually write this as a tensor equation, and then everything gonna look so much nicer. If you wonder tonight, go read something called normal equation. Then you're gonna see the general pattern of this guy. Then you just do this. Return np linear algebra dot solve A and B. Done. Boom. And then you do base param and arms height. I put the mom first, but here I put the father first. This is actually what they do in when they try to predict the condominium price. Okay. This is actually what they actually do. So because it's clear that the condominium price depends on like the area, or depends on the depends on like how many bathrooms, depends on how many bedrooms. So it's quite linear, and depends on the zone as well. So they do this for each zone. Okay, so that means yes is going to be C mount, see that, and X0 is this. C mount, right? Plus X0. Okay, and here you will quickly repeat the space 0, 0, and what 100, 200, 230. Okay. So I went pretty fast, but I think you get the core idea. I know there's some detail that I brush over, and then you can go look that up real quick. But I want to teach you the following, right? That it doesn't matter if you have higher dimension. It doesn't really matter. This is all you do, right? It's exactly the same problem if you try to do least square, right? You are essentially solving linear equation. Okay? You're essentially solving linear equation, except you just need to figure out what to solve, which you can do that by taking derivative, set it equal to 0, and then you have multiple equation. You can solve for it really quickly. Okay. So here's the idea, right? So the thing is, when you try to plot this, last time we can plot this because you only have one y and one x, right? You can plot, there are two numbers like 2D, you can plot for it. right? You can plot for this guy. That 2D, you can plot for this. But for this one, you can't really plot it. If you want to plot it, you need to plot it in 3D, and then you're going to go up to 4D, 5D, and then you have no idea what you're looking at anymore. So the recommendation is the following. If you are good, right? If your guess is good, then your guess should be really close to the actual. So let me put the label as well. So what I'm plotting here is the actual versus the guess. So the x-axis is going to be the actual. This is the guess. Okay, or the name, the official name is actually called the residual, but you don't really care. If your guess is good, if your guess is perfect, you should lie on the orange line, which is x equal to y, right? That's why I plot this line over here, x equal to y. So if your guess is a little bit off, then you're gonna be off like this. Then this is cool. At least you're doing the right thing. You know you're doing the right thing if it looks like this. Okay, it's not gonna be perfect. You're gonna be off by a little bit by whatever physics you didn't capture. Okay, any questions so far though? Any questions so far? I want you to see that this technique is so powerful. Okay, any questions so far before I show you something really quick for the next one? Let me push this one on the GitHub as well. Okay. So this is a really powerful technique. You can do any number of dimension you like. Like if you have 100 variables, yes, you can. There's no problem. There's nothing preventing you from doing it, right? Okay. So, but if you think about it, this guy, if you look at all the physics law that you learned so far, especially for risky, all the physics law that you learned so far, most of the law are of this form. Okay, most of the law are going to be of this form. This is called power law, right? So for example, F equals to ma is m times a. You rarely see the physics formula that two things are added together. Rarely, very rare. Okay. So, but this one, if you try to take the derivative, you're gonna see everything like combined, and then you're gonna feel so sad that you cannot solve for it. Okay, you're gonna feel so sad if you try to take the derivative by alpha, beta, and gamma, right? So for example, F equals to ma, k is 1/2 mv squared, right? Or c is 1 over mu epsilon, and so on. So the physics that you see gonna look like this. Okay, or even water flowing in the pipe that looks like the delta P, the pressure and the flow rate are linear to each other, but it depends on the length square and radius to the fourth and so on. Okay, so here's what we normally do. When we see things like this. Typically, when even after you do machine learning, this is one of very important trick, because you know that nature, for some reason, natures love power law. I don't know why. Maybe there's some really deep reasoning, but I don't know why. Okay, because all the physics that you see gonna look like this. So, but if you see this, you're gonna cry. You don't know what the alpha, beta, and c is. But there's a really good trick. How do you turn this into something added together? How do you turn the product into the sum? Anyone? Can someone tell me? Something that you learned in high school and no one tells you that it's so powerful. How do you turn the product into the sum? Anyone has a good idea? What did you learn in high school? How do you turn the product into the sum? Take the log. Very good. That means you learn something in math, right? So if we have like y, whatever the physics that we're trying to guess is k a to the alpha, b to the alpha, and c to the alpha, right? If you take the log, right? So that means log of y is going to be log of k plus what? Alpha, log of a plus beta, beta, and the other one is gamma, beta log of b, and gamma log of c. So let me put all the I so it looks more familiar to you. Let me put all the I in. Now it looks close, very close to what you can, right? So that means whenever you have the data, you're going to have the y, a, b, and c. You go collect the data, right? You go collect the data, y, a, b, and c. Okay. And then what you do is you turn this into log of yi, log of y, log of a, log of b, right? Log of c. Certificate. You turn it into a log of data. Therefore, then you're done. You're really done because this thing is like your new data, right? Your new data is a log transform of the raw data, which means it's gonna be linear in that space, in log space. Okay, so that's good, right? So the thing that we did, and even though we call it linear regression, is really like very powerful. It can do power law as well. Okay, there are certain type of things it cannot do, which we're gonna talk about next time. Okay, is everyone good? Let me show you something more concrete. Okay, show you. But everyone get the idea, right? If you take the log of the power law, you get exactly what you learned today. And power law is like, I don't know, 90% of the physics. Okay, if you learn it with physics data, this is the first thing that you should try. Take the log, and then you will be really close. Take the log, and you will be really close to the data. Right? In machine learning, if it doesn't work, then the first trick that you should try is to take the log of the data and put it in as a new data. Okay, so suppose the following. Okay, suppose the following, that you forgot what kinetic energy is in physics. So you have K equal to CV to the some power. You don't remember this, number 2, right? So what we're gonna do, you can go collect the kinetic energy somehow. You can, let's say that there's a kinemometer or something that measures kinetic energy and the velocity. You're gonna get this graph, right? But then you want to know what is the power, what is the alpha, and what is C. Okay, what is the power of alpha and what is C? So here's what you do, right? You have V and K. So kinemometer, maybe that might be a word. Go figure out. I don't know. Maybe. Okay. So you have log of V, right? So you can do this NP dot log of V and K, the kinetic, right? Log K. So that's gonna be NP dot log K, and we're just gonna copy the baseline over here. Where's that? The baseline. Where's that? The baseline over here. Done. Right? Because this thing solves AX plus B. This thing like solves AX plus B. Right? This thing solves AX plus B. So here's what I'm gonna do. Let me show you. So I just do baseline of log of V and log of K. Wait. Y or X first? Okay. Log of K. And then now I get already like, let's call that little a and little b. Oops, baseline. Okay. But that a and b, right, is going to be some funny function, right? So a is going to be the alpha. So if we can look at here, so we have k is cv to the alpha, right? We take log, it's going to be log k is log of c plus alpha log of v. So that's your a, the thing that is in front of your variable, and that's your b. Okay. So that means alpha is just a, and c is exponential of b. Okay, I just reverted because b is log c, so I just reverted. Okay, that alpha looks like number 2. Oh, it's alpha. And then you can do the following. You can do the following, right? You can do plug and then c times v to the alpha. I don't know if it does the right thing. Let me guess it does the right thing. Oh, I want it to be there. This one. Let me do. You can actually sort the V, but yeah, I'm too lazy. Right now, you can do the power law like magic. Okay, the data and the gas are almost exactly the same. Okay, any questions so far? Or any questions so far? I want you to see that we start here today from linear equation, right? And then we went to like solving, okay, maybe fitting a straight line, that's cool, right? Fitting a straight line, that's already like cool enough. And you figure out that fitting a straight line is actually means fitting any line, which means, okay, that's not stopping you from doing parabola. You can do x cube if you like, right? Or you can even go to higher dimension if you like. And the technique that we learn is more generic than just linear. You can do power law as well, as long as you can transform your power law into linear equation. Are we good? The homework this week is actually fun. Which homework every week is fun, but no one is quoting Luigi yet. So I'm guessing no one is doing the homework yet. So please do it. Please do it. Exercise 4. Let me show you the homework 4. Where is it? Homework 4. Homework 4. Homework 4 will be the last homework for the midterm though. But we're gonna keep going though. We're gonna keep going non-stop. But homework 4 is the last homework for the midterm. So homework 4, you're gonna find all the peaks. Okay. So this one is hard though. This one is hard. This is, think about this. If you try to do any experiment, a lot of time you want to find a peak. You want to locate the peak. You're gonna write a function that locate a noisy peak, a peak of noisy data. Okay. The rest are actually pretty simple. So by the way, number 3 is optional. Like I said, this is optional. So optional. Okay. The rest are actually pretty simple. A guess of the peak is actually a guess of parabola. I actually give you the hint. Actually, I didn't give you any hint because there are like 10 ways to do it. Well, I give you some hint about fitting the parabola around the peak and figure out where the peak lies. Okay, this thing is actually very very common when you try to analyze any data. You want the peak, and then you want to locate the peak without the noise because your data is going to be so noisy. You might say that, okay, a time peak is here. No. But if you look at it, peak is like around there, right? Yes, something like that. That works too. There are many methods to solve this. Do something sensible. Do something sensible. That's all I ask. Okay? Do something sensible. Okay, please do the homework though. I see you guys into the homework, but the midterm non-sensible means use your eye and look at it. Like if problem 1 return 0.7 or something, that's not sensible. When will the midterm be? Good question. When do you want it? I kind of want it after the next week. Yeah, I kind of want it on week 6 though. Let's okay. Here's your homework. Here's your real. Here's the homework. After everyone finish, you should finish homework for by next week, and then I'm gonna give you another week because I know not everyone gonna finish homework for. So let's put this midterm gonna be week 6. We get, but you have yeah. Unless you really want 7, that works too. Okay, here's your job. Go figure out when is other class midterm. So it's either 6 or 7. Okay, which one that's fine by you. The midterm is going to be much easier than the homework. It's going to be very close to the exercise, but there's going to be some part of it that requires your imagination. So if you can do the exercise in class, you should pass the course easily. Okay, so but the homework is like for fun. Okay, homework is for fun. If you have questions about the homework, scream on Discord. Someone gonna come and help you. Okay. Any questions so far? Though? Any questions? So homework 1 to 4. This is what we're gonna cover. Okay. A lot of things we learn in this class going to be optional. You're not going to be tested on it. Okay, especially at the very end, you're going to learn how to make something really cool. Okay. Any questions so far though? If not, we're going to call it a day and going to see you next week. Bye everyone.